Welcome back, Algebra 1. We are entering Unit 7, and we're going to be covering geometric sequences and recursive functions. This is going to look a lot like what we did earlier in the year in Unit 5, where we worked with arithmetic sequences. Today we're going to talk about geometric sequences, but a lot of the terms are going to be the same as you've seen before. So just a review. A sequence is a list of ordered numbers that has some sort of infinite pattern. 3 dots at the end indicate that the pattern continues infinitely. So let's see if you can figure out what the next number in each one of these sequences would be. In this first sequence, we can see it's increasing from 5 to 10. That's adding 5, but let's make sure, does that still work? 10 plus 5 is 15, 15 plus 5, 20, and so on. So indeed, we are adding 5 each time. The next number in my sequence is 30. So for example, B, let's see if that pattern still works. If I add 6 to 2, I get 8. But if I add 6 to 8, that does not give me 32. So let's try a different pattern, maybe multiplying. So 2 times 4 is 8. 8 times 4 is 32, 32 times 4, and so on. So I'm multiplying by 4 each time. I might need to grab a calculator to do 512 times 4. 248 is the next number in that sequence. Let's see if you can figure out example C on your own. Example C, we're subtracting 3 each time. So if I do 2 minus 3, that would give me -1. D is tricky. Let's see if you can get D on your own. This one was tricky. We're multiplying by 1/3 each time, or you could think of it as dividing by 3 each time. Those are equivalent statements. The next number in my sequence is 1/9. So just to sum that one up, since it was tricky, dividing by 3 or multiplying by 1/3, those are equivalent things. I do prefer multiplying by 1/3, even though we don't love fractions, it does make a little more sense, and it makes it easier to find our next number if we think of it that way. Previously, we talked about adding or subtracting values from our sequences. In this lesson, we're going to focus on multiplying constant terms. These are called a geometric sequence. Before we had the arithmetic sequence, now we have the geometric sequence. The common ratio is the value being added to each number in a geometric sequence. This is noted with the variable r. So before, when we did arithmetic sequences, we talked about the common difference, and that was the letter D. Now we're going to be using the variable r for the common ratio, the number being multiplied each time. So if I go back to this, multiplying by 1/3, that was my common ratio for that sequence. In my example above, two of those examples were geometric sequences. We multiplied. In the first one would be example B. So in geometric sequence B above, we multiplied each time by 4. And in geometric sequence D, that was the other one that was a geometric sequence, we multiplied by 1/3 each time. And just for review, in sequences, we often refer to the nth term. This is the count of the number we desire in the sequence. The n will be replaced with a number or lets us know to use a pattern. And another review, a recursive function for a sequence is one that creates a mathematical rule based on an nth term and refers to the previous term or the next term. So recursive functions are often used in computer programming. Let's see how a recursive function would look for a geometric sequence. So, and I know this one's going to be a geometric sequence because I have an R, not a D. And I can also tell from my rule here that I'm going to take the value I'm on now and I'm going to multiply it by my R. We can see that my number that I'm on now is 6. So I'm going to go to that current term column and begin there. So I've got n equals 6. We know that a of n, or a of 6, equals 15. So we're just going to leave that alone. So there's our a of 6. That's the current term I'm on now. To go to the previous term, that would be n minus 1. So n minus 1 would be 5. And then in order to go back a term, instead of multiplying by r, I would divide by r. And I just noticed there's a mistake in my notes, so just change that multiplication symbol. That should be a division. I should be dividing. So that means I would take r and I'm going to divide 15 by r, divide 15 by 3. And that is going to equal 5. And finally, we're going to find that next term in my sequence, so that n plus 1. Remember, n was 6. That means that n plus 1 is 7. I'm looking for the 7th term in this sequence, and this is the correct rule. So we're going to take the number we're on now, which is a of 6, and we're going to multiply it by r, which was 3. Our 7th number in our sequence would be 45, and it makes sense. 5 times 3 is 15. 15 times 3 is 45. So those are the 5th, 6th, and 7th numbers in the sequence.